All right, today we're going to continue our discussion on polynomial division. And again, the reason we're going to be spending so much time here is that dividing polynomials is an important skill as we begin to factor polynomials in the coming days. All right, so we're going to find each quotient by using the generic rectangle. Remember, a quotient is the answer to a division problem. Some vocabulary change. And again, just like yesterday, we're going to write any remainder as a fraction. All right, so here we go. I have an x to the fourth plus dot, 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 divided by an x to the first, dot, 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 which would give me an x cubed, dot, 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 which means I need a column for an x cubed, an x squared, an x, a constant, and a remainder. So 1, 2, 3, 4, 5. So I'm going to have my 2 rows, and I need 5 columns. 1, 2, 3, 4, 5. And that last column, if there's anything in it, will be my remainder. All right, let me get some other markers out here like I used in yesterday's lesson. All right, so here we go. Let's just start in here. We know our first term is x to the fourth, right? This is what goes inside the box. And so we need an x cubed above it. And x, now we'll fill down. X cubed times negative 2 is negative 2x cubed. All right, so that starts for us that diagonal. Those 2 boxes there are my x cubes. X cubes, I need a total of negative 8 of them. And right now I have negative 2, so I need another negative 6. Right? Those 2 boxes together need to add to negative 8. And then we start over. On top of this, let's see, to multiply by x, I need a negative 6x squared. Do a double check. Negative 6x squared times x is negative 6x cubed. Let's go down here. Negative 6x squared times negative 2 is a positive 12x squared. That sets up for us our next diagonal. Those are my x squareds. Right now I have 12x squared. Oh, we don't have any x squareds in here. Interesting. So this is like a plus 0x squared. I don't want any x squareds. But right now I have 12 of them, so I better take them away. That's what makes this a little bit different. We just need to pay attention, don't we? All right, starting over. I'm going to need a negative 12x on the top, which gives me down here a 24x, which starts my next diagonal. All right, so we've got our 24x there, and we need a grand total of 12x. So I have too many, so I need to take some away, and I need to take away 12 of them. All right, put a negative 12 up here, and negative 12 times negative 2 is a positive 24, which starts our next diagonal, our last diagonal, in fact. I need a grand total of 8 in the box, and right now I have 24, so I better take some away. I need to take away 16. All right, so here's my remainder. Right, we don't start over. We don't go what goes above the box. Nothing goes above the box for a remainder. So my answer is x cubed minus 6x squared minus 12x minus 12 plus my remainder is negative 16. My divisor was x minus 2. Now we could also, right, adding a negative, you can also write x cubed minus 6x squared minus 12x minus 12, and you can say minus, and then just a 16 over x minus 2. That's the same thing, right? Adding the opposite, which is the same as subtracting. So you can put the negative in the numerator or just out in front of the term. Same thing. Okay. All right. I don't think we need to do the next two, to be honest. I think with the lesson we did yesterday and then what we just did here, I think we can go ahead and skip slides 2 and 3. So I'm going to come down here to slide number 4. This is super tiny. X cubed minus 1 all over x minus 1. Well, as we just saw, maybe we should be thinking of this as x cubed plus 0x squared plus 0x minus 1 all over x minus 1. All right, so we have an x cubed plus dot 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 divided by an x to the first dot dot dot, which is going to give me an answer that's an x squared. So I have a quadratic, which means I need an x squared, an x, a constant, and room for a remainder. So I'm going to need 4 columns. All right. So we've got our x minus 1, and then there's my remainder column. All right, here we go. My first term is x cubed, goes in that top left-hand box. X squared times x, perfect, is going to give me that x cubed, and then we'll take those dimensions down and fill in the bottom left. X squared times negative 1 is negative 1x squared. And that starts for us a diagonal. So right now, those are my diagonals. Right now I have a negative x squared. But I don't want any x squareds, so I'm going to put a positive 1x squared in this box, right? Add them together, we get 0. And then we start over. X times x gives me x squared. X times negative 1 gives me negative 1x, which starts the next diagonal. So I don't want any x's, and right now I have a negative 1x, so let's add a 1x, and there, that gives me my 0. So I think I just need a positive 1 up here. 1 times x is x, 1 times negative 1 is negative 1, which starts the next diagonal. And my constant is negative 1. I already have a negative 1, which means I don't have anything left over, right? You can put a 0 there. You could just cross it off because we don't need it. There's no remainder, which is different from the last few that we've done, isn't it? So my answer, straight across the top, x squared plus x plus 1. And because there's no remainder, that means x minus 1 goes into this cubic polynomial evenly. All right, I'm going to flip it over. All right, so the last few examples, well, all of the examples and all of the homework questions we've done so far, we've been dividing by a linear factor, meaning x to the first. X minus 2, x plus 3, x minus 5, 2x plus 1, right? The exponent in the denominator was never anything other than a 1. Well, now you can see on this one and on their next example, I'm now starting to divide by a quadratic. Well, let's talk about how that changes things. First of all, I'm dividing by a trinomial, which means I'm going to want 3 rows. The other thing is if I'm doing an x to the 4th divided by an x squared, my answer is going to be an x squared. We said an x squared, it needs an x, a constant, and then possibly a remainder column. So I need 3 rows, but I still need 4 columns. 1, 2, 3. I never make it long enough. But even still, we're never going to use that bottom right-hand corner, and those are some patterns you'll start to see. All right, so down the left side, x squared, positive x, negative 4. All right, so here we go. My first term, x to the 4th, goes in the box. Above it, I'm going to need an x squared. So x squared times x squared is x to the 4th. And then we're going to fill in this whole column because we can. X squared times x is x cubed, and x squared times negative 4 is negative 4x squared. Now honestly, that's set up for us. That started 2 diagonals, but we're going to focus just on 1. Oops, let's circle this. These are my x cubes. So right now I have 1x cubed, but I need a negative 1x cubed. So we could go off to the side of our paper and say 1 plus what gives me negative 1. And so if I subtract that 1, I get question mark equals negative 2. So if that helps, then by all means, let's do that. And then I'm going to start over. Let's see, above this I'm going to need a negative 2 and an extra x. And now I can fill in this whole column. Negative 2x times x is negative 2x squared. Negative 2x times negative 4 is a positive 8x. Now, come all the way back here. 1, 2, 3 boxes in the diagonal. These are my x squareds, and I need a grand total of negative 3 of them. Right now, these 2 boxes together, I have negative 6x squared. Negative 6 plus what gives me negative 3? And the answer is 3x squared. And I'm going to start over. Let's see, the only thing I'm going to need up here is a 3. 3 times x squared is 3x squared. 3 times x is 3x. 3 times negative 4 is negative 12. All right. Let's check our diagonal. 8x, 3x plus what gives me 11x? Oh, actually we already have 11x, so we don't need any more x's. Perfect. This diagonal I haven't touched yet. Those are going to be my constants. I need a total of negative 12, and I already have negative 12, so I don't need... Oh, perfect. There's no remainder again. There's nothing in those boxes. What's my answer? Across the top, x squared minus 2x plus 3. All right, let's try one more of those. And if you would like to try it on your own, you can pause the video and then you can unpause and then fast forward and see if your answer looks like ours. All right. So yet again, just like on the last one, we have an x to the 4th divided by an x squared, which told us back here we need 4 columns. So I'm dividing by 3 terms, so it's going to be another 3 by 4. 1, 2, 3, 4. All right. Down the left side, x squared, negative x, positive 2. All right. Let's see, I'm going to need an x squared up here. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times 2 is 2x squared. That starts this diagonal right here. We do one diagonal at a time. I need 2x cubes. Right now I have negative 1. So negative 1 plus what gives me a positive 2? And that's a 3, isn't it? So I need a 3x cubed. And do a quick check. Add those together. And then start over. I'm going to need a 3 and an extra x. 3x times x squared gives me 3x cubed. 3x times negative x gives me a negative 3x squared. 3x times 2 gives me a 6x. All right, so my next diagonal has already been started and a lot of it's filled in. Those are all my squared terms. So right now, when I add these together, I have a negative 1x squared, but I need a total of 4. Negative 1 plus what gives me 4? Question mark equals 5, doesn't it? 5x squared. Start over. All right, I need a 5 up here. 5 times x squared. 5 times negative x. 5 times 2. We've got this diagonal right in here. 6x and a negative 5x is a 1x. but I need a grand total of negative 2x. So again, go off to the side of your paper. Right now I have a 1, right? 6 minus 5 is 1, but I need to get a negative 2. So how about a negative 3x? All right, and then my last diagonal, right there, I need a total of 10. Oh, and I actually already have 10, so I don't have anything in that box. All right, so my answer, x squared plus 3x plus 5. My remainder is negative 3x, and my divisor was x squared minus x plus 2. Okay, now I didn't intend for us to have a 0 in this box, and it doesn't matter. I mean, this is the correct answer, but I really want to make sure we address what our answer would look like if there was a number there. So, for instance, if this was a negative 3x, and let's say that was a 10, then my answer would look like this. X squared plus 3x plus 5, and then my remainder would be negative 3x plus whatever that number is. I called it a 10, all over x squared minus x plus 2. So we don't need two separate fractions. We're just going to say this is what's left over, these two terms. So we'll put those two terms over that divisor. So I know that wasn't the answer. I just thought it would turn out a little bit differently.